Good evening all. Am I audible? Good evening all. Am I audible?
Yes,
Yes,
sir.
sir.
Okay, thank you. So in the previous class, we were discussing about some of the important problems in Z transform. Today we'll continue with that uh, the set of problems which we have already known about. Okay, so I have shown some of the problems which we are going to solve based on the concepts which we have understood. Now let me share the screen. So this is the problem which we had solved previously. E to the power minus n u of minus n minus 1. The ROC of this one is here and the answer for this problem is this. Okay. Now we'll start with our next problem. This kind of problem already we have solved. That's why I'm not going for this one. Say just we'll have a glance at it. X of n is given by 5, 2, minus 2, 1, 1, minus 3. So this is x of 0, this is x of 1, x of 2, x of 3, whereas this one is x of minus 1, x of minus 2. Okay. Now if you substitute for the z n value here, that is from n is equal to minus 2 to n is equal to plus 3. So we have changed the limit, and if we go on substituting n is equal to minus 2 up to plus 3, we will get this sequence. Okay, and this is our Z transform. For ROC, it is entire Z plane except Z is equal to 0 and infinity. If you substitute 0 for these terms, 1 by Z, 1 by Z square minus 3 by Z cube, they will become 1 by 0 means infinite. Okay. If Z is infinity for these terms, not for this one, except this term, these two terms will lead us to infinity, because 5 into infinity is infinity, 2 into infinity is also infinity. So two values, z is equal to 0 and z is equal to infinity, except these two values, any other value z can take, that is z will have an ROC from 0 to infinity. Okay, now this is the next problem which we have. This is the problem. Problem is a to the power n from 0 to n minus 1. Okay, and a is less than 0. less than or greater than? A is greater than 0, less than 1. This is 0. So what is this? This is our x of n. Okay. So for this problem, find x of z. We need to find x of z. Today's problem number 1. Okay. So as we know, what is the Z-transform equation? X of z is equal to summation n is equal to minus infinity to plus infinity x of n z power minus n. So now the limits is from 0 to n minus 1. That's why we can directly write n is equal to 0 to n minus 1 a to the power n z into minus n. Okay. For this we have a standard equation. Here you can see this is our standard equation. So using this and assuming that a is not equal to 1, here it is for b, we can assume for a. So what we can write is, so let me simplify it, n is equal to 0 to n minus 1 a into z inverse to the power n. So we know that summation n is equal to 0 to n minus 1 b power n is 1 minus b power n divided by 1 minus b, provided b not equal to 1. Okay, using the same logic, we can write x of z is equal to 1 minus a z inverse to the power capital N divided by 1 minus a z inverse, provided a z inverse not equal to 1. Okay, so this is our equation. So using this relation, if we simplify this, what we get is 1 minus a to the power n divided by z to the power capital N, 1 minus a by n. Okay, now we can write it as 1 minus a by n, that is z minus n minus a, z to the power n minus a to the power capital N divided by z by, sorry, must write as power. Now this is n minus a by n. So you know that this will become z to the power n minus a to the power n divided by, did I make a mistake here? Yes, it is a by z. So z minus a by z. So what we will get is, this as z minus a and this term and this term. So it will be z divided by z power n. Okay, or we can write this as 1 divided by z power n minus 1. This I have taken into denominator, and I can write the remaining part as same. So this is the x of z equation. Okay, so for the given sequence, this is the x of z equation. But the problem is not only to find out z transform, give me a second, there is some problem with this cursor. Okay, now the problem is find x of z and plot the poles and zeros. So we need to find out what are poles for this x of z and zeros of the x of z. Zeros of the x of z. So finding poles and zeros and plotting them. So this is our next task. Poles means what? Poles are the values of z which make x of z equal to infinity. Okay, values of z in the denominator, in the denominator. Okay, zeros are the values of z in the numerator which make x of z is equal to infinity. So these are the values of z we need to find out and call them as poles and zeros. So for us, we need to look into here and here for poles and at this point at for zeros. Okay, so there are how many poles? Z to the power n minus 1 poles and z minus a, this is another pole. So these are the poles. Okay, if you have n is equal to 10, z to the power 9, so a pole of order 9, that is 9 poles are there on one top of another, and there is another pole at z is equal to a. So these are the poles. When it comes to 0, z to the power n minus a to the power n is there. So zeros will be equating z to the power n, a to the power n equal to 0, z to the power n is equal to a to the power n. So there are n zeros. Okay, so now let us try to find out this answer, whatever I have explained now. So poles are pole of n minus 1th order at z is equal to 0, and there is a pole at z is equal to a. So if I put 1 by 0, that is z is equal to 0, that is the pole at n minus 1th order. This is your order, right? Z to the power. So at z is equal to 0, there is a pole of n minus 1th order, and there is another pole z minus a equal to 0, that is z equal to a at this point. These are the poles, and there are n number of zeros, and they are located at the points So n number of zeros. Why we are saying capital N number of zeros? Because z to the power n is equal to a to the power n. Okay, z to the power n is equal to a to the power n. So here there are total n number of zeros, and it is given by this equation. Number of zeros is, it is just based on r into a to the power j omega. We know that z is given by this, right? So based on this only we have written. Okay, how many number of zeros will be there in this? It is given by a into e to the power j 2 pi k divided by n. Omega is 2 pi. When I say omega in digital, it is nothing but 2 pi into n divided by n. Instead of n, we are using k as a variable. Okay. And another interesting point is to note, the 0 at k is equal to 0. Let me tell with respect to the above equation itself. Okay. Now look at this equation. If I substitute z is equal to a, what will happen to this equation? 1 divided by a to the power n minus 1. We leave it this part. Whereas this one, a to the power n minus a to the power n divided by a minus a. So you can see here, this will lead us to 0 as well as this will lead us to infinity. Correct? So there is one point where 1 0 cancels one pole. It is a 0 by 0 rule. Correct? An minus a to the power n minus a to the power n is equal to 0, and a minus a is also equal to 0, 0 by 0. So here a pole is cancelling 0. Sorry, a 0 is cancelling a pole. And thereby we don't get any pole or 0 at z is equal to a. Apart from that, all the other zeros will be there, and they are given by the value k is equal to we need to substitute k is equal to 0 to get first 0. Okay, but it will become z of 0 is equal to a. This is one pole, but it is getting cancelled with the 0. That's why we have to substitute for k is equal to 1, 2, up to what? Up to capital N minus 1, because we have said that there are n number of poles. There are n number of poles, that is from 0 to capital N minus 1. So now we are left with only n to n minus 1. This is a typical problem. No need to worry about different problems on this concept. This is a typical problem. If you understand this, you will be able to solve any problem given to you. So here, to find out number of zeros, this is the equation we use. And pole 0 cancellation at z equal to a. Now, remaining zeros can be calculated using the same equation, substituting k is equal to 1, 2, up to n minus 1. And the plot, what we get is this one. There is a pole at the center, and pole 0 cancellation. Here one pole was there and there was 0. So pole 0 cancellation happens here. That's why it is the empty space here. Otherwise, we have zeros around the circle. Okay. N minus 1th order pole will be at the center. N minus 1th order means, if I say n is equal to 8, there will be 7 poles. Okay, here the pole 0 plot is for n is equal to 8. N is equal to 8 means your equation. Let me write the equation, then you will understand. 1 divided by z to the power 8 minus 1, z to the power 8 minus a to the power 8 divided by z minus a. This is our x of z equation for n, capital N is equal to 8. So 1 by z to the power 7 and remaining will be same. So there is a pole of order 7, n minus 1th order. Okay, at z is equal to 0. At z is equal to 0, if you substitute z is equal to 0, 1 by 0 is infinity. That's why at z is equal to 0, there is a pole of order 7. And there are 8 zeros. In that, 1 0 cancels, because when z equal to a, z will become equal to a. What will happen? 1 0 will cancel with 1 pole. So there will be 7 zeros. Okay, there will be 7 zeros, as you can see here. This is 1 0, second, third, fourth, fifth, sixth and seventh. These are plotted based on this equation only. Okay, so here 1 pole and 0 was there, that was cancelled. Okay, that is the typical kind of problem. If you have any doubt, you can ask, or else we'll continue with the next problem. You can ask the doubts in regular class also regarding this particular concept. Okay. So next problem is, find the Z transform of a to the power n cos omega naught n un. Okay. This problem, how to solve? Anyone, can you tell how this problem can be solved? Yes. Anyone? Let me know how to solve this problem. It is cosine signal multiplied by a into n. Okay, using properties, can we solve this problem? Yes. I am waiting for your response. How many of you have solved this problem, cos omega naught n? I had given this as a homework, right? So if you have solved this problem, then you would have got this as answer. Okay, we have solved it halfway and I left for you to complete it. Correct? So this is cos omega naught n u of n, we have already solved. If this is multiplied by an exponential, what is the answer? It is based on the properties. The property is multiplication property, multiplication by an exponential. So we have a property that x of n, if it is multiplied by a to the power n, then the Z transform will be x of z by a. If x of n will give us a Z transform as x of z, then if you multiply with the exponential, then Z transform will be, wherever z is there, you have to replace by z by a. So that is the property. Using that property, we can solve this problem and simplify it. Okay, we can solve and simplify. The same thing we have done. Already we know what is cos omega naught n into u of n. This is the answer. Okay. Now wherever z is there, z is replaced by z by a, or this is equivalent to z into a to the power minus 1. So here z square is there, that's why we can take this whole square. Same thing is done here. Okay, after that a minus z whole square is taken common. If we take common, what will happen? The answer will become 1 minus a z inverse cos omega naught. Is that need to be solved? Minus a inverse, sorry, a inverse z whole square is taken as common. This will become 1 minus z inverse divided by a to the power minus 2 z to the power 2. So this minus 2, if it goes above, it will become plus 2. This plus 2, if it goes above, it will become minus 2. So this 2 cancels with minus 1, and this z cancels with this one, and it will become minus 1. So it is a into z inverse. Understood? This z inverse, a into z inverse. Similarly, at the denominator end, if you take z into a inverse whole square as common, it will become 1 minus 2az inverse cos omega naught plus a square z to the power minus 2. Okay, and ROC, as we know, for cosine signal, cosine and sine signal with u of n multiplied, ROC is always greater than z. Okay, always greater than z for u of n signals or right sided sequence. Now we are replacing z by, sorry, z greater than 1. Now replacing z by a. So it is greater than 1. That means ROC is magnitude of z greater than magnitude of a. So here it is. So this is the ROC. Okay. If multiplication by this exponential was not there, then ROC is greater than 1. Now ROC is greater than a. Okay. So this is our last problem on the standard note. Now similar problem you can expect for say, let me write it as similar kind of problem you can expect like what is a to the power n sine omega naught n into u of n. I have solved for cosine. You can expect x of n given by this. So then we have to take what is the x of z of this sine omega naught n. Then we need to change wherever z is there, we have to replace it by z by a and simplify it. Again, ROC for this also will be from magnitude of z is greater than magnitude of a. So the same rule is applicable here as well, because it is multiplied by u of n. Okay, try this problem. A to the power n sine omega naught n u of n. Okay, now moving on to the very interesting part of this. Using the already learned concept, we are going to solve the problems. Now you can see instead of a to the power n, b to the power n, we have the numbers. Okay, numbers like 1 by 2, 2, 3. These are nothing but a and b, general form. So let us consider our problem as x of n is equal to given problem, x of n is equal to 2 to the power n u of n plus 3 into 1 by 2 to the power n u of n. So this is the problem given. We need to find out Z transform and write the ROC. Okay, this is the problem. Now we know the equation as usual. We can write x of z is equal to n is equal to minus infinity to plus infinity x of n z to the power minus n. This we can rewrite as n is equal to minus infinity to plus infinity 2 to the power n u of n z power minus n. Okay, then n is equal to minus infinity to plus infinity. 3 I will write outside. Okay, it is a constant, that's why it does not depend on n. 1 to the power n u of n z to the power minus n. Since u of n is there, the limit will change from 0 to infinity. So directly we can write n is equal to 0 to infinity 2 to the power n z power minus n plus n is equal to 0 to infinity 1 by 2 to the power n z power minus n. Okay, now this is easier to solve now. So let us take 2 into z to the power minus 1 power n plus n is equal to 0 to infinity 1 by 2 into z to the power minus 1 to the power n. So this is our standard form of the equation. What is that? We know that summation n is equal to 0 to infinity a to the power n is represented as 1 divided by 1 minus a, provided a greater than 1. Okay, so using this we can write above equation as 1 divided by 1 minus 2z inverse plus 1 divided by this 3 I have left, right? Let me write that 3 was there. 3 into 1 divided by 1 minus 2 into z inverse. Okay, now let us simplify it. So 1 minus, so for those who are not able to understand, for them it is 1 minus 2 divided by z, z inverse is written in this fashion, plus 3 1 minus 1 by 2 z. Okay, now we can write z divided by z minus 2 plus 3 into z divided by z minus 1 by 2. Okay, this will not take into the numerator 1 by 2. It is kept as it is. Okay, so according to the given x of n, this is our x of z. And what is ROC? ROC, for ROC we have to look at this equation, very first equation. That is ROC is 2 to the power z inverse is greater than 1. Correct? Sorry, it is greater or yes. Give me a second. Yes, it is a less than 1. Magnitude of a is less than 1, right? So a less than 1. So because of that, we can say 2 to the power z inverse is less than 1. That means 2 by z less than 1. This implies magnitude of z is greater than 2. Similarly, for this one, ROC is 1 by 2 z inverse was there, right? It is less than 1, or 1 by 2z less than 1, or z is greater than 1 by 2. So combined ROC is z greater than 2 intersection magnitude of z greater than 1 by 2. So what is the meaning of this? It is very easy to understand. Z is greater than 2 means it is including z is greater than 1 by 2, right? If I say something, this is 2 and this is 1 by 2. If I say ROC is greater than this one, it will not include any of the poles. So it is obviously 1 greater than 1 by 2. That's why we can write the ROC as Z greater than 2. Okay. So this implies ROC of this is magnitude of Z greater than 2. Okay. And this is the answer. X of Z is this one, and ROC is this one. Okay. Any doubt regarding this problem? This is the easiest problem based on the concepts which we have learnt already. Okay. So this can be simplified, and simplified version is here. No need to worry about that. If you write this one also, it's fine. Okay. So now the second problem is here. 3 into minus 1 by 2 to the power n u of n minus 2 3 to the power n u of minus n minus 1. Okay, this is the problem. So x of n is equal to 3 into minus 1 divided by 2 to the power n u of n minus 2 into 3 to the power n u of minus n minus 1. Okay, this is the given equation. For this x of n sequence, we need to find out x of z and region of convergence. For this, we have to go for in the first step. We have to write our equation minus infinity to plus infinity x of n z power minus n. So what is our x of n? 3 is a constant. I will write it outside. Minus 1 by 2 to the power n. It depends on n. That's why we'll write it inside. Into u of n minus 2. I will write it outside. Then we have 3 to the power n u of minus n minus 1 z to the power minus n. Okay, so it indicates the limits of n is equal to 0 to n equal to infinity. This indicates limits are from n is equal to minus infinity to minus 1. Okay, minus infinity to minus 1. So we will remove that and we will write 3 into n is equal to 0 to infinity minus 1 by 2 n z power minus n minus 2 into summation n is equal to minus infinity to minus 1 3 to the power n z to the power minus n. Okay, so this is the standard way of representing, right? So let us consider only this part. What is the simplification of this? This can be written as minus 1 by 2 z to the power minus 1 to the power n. Correct? So this is the equation. Similarly, this is minus 2 n is equal to minus infinity to minus 1 3 z inverse to the power n. Okay, so now this is easy to solve for us, a to the power n, but here n is from minus infinity to minus 1. So what we can do, we will substitute for this part. For this part, m is equal to minus n. M is equal to minus n. Then what we'll get, when n is equal to minus infinity, m will be plus infinity, and if n is equal to minus 1, m is equal to plus 1. So already we have solved this kind of problems. So now let us replace it, m by, so this is the other part, let m is equal to minus n. If you do that, then it will be n is equal to infinity to 1 and 3z inverse to the power minus m, because n is replaced by m is replaced by minus n, n means minus m, reverse. Now sorry for this will be m. Variables we can use any m, n, k, p. Okay, n is equal to 0 to infinity minus 1 by 2 power z inverse power n minus 2. This I can write m is equal to 1 to infinity 3 power 3 into z power minus 1 m. So if I change, that is if I add from infinity to 1 or 1 to infinity, both are same. That's why we can write it in this fashion. Okay, but now what we know, if we take the summation from m is equal to 0 to infinity, we'll have to subtract by 1. So let us write that 3 z inverse to the power m minus 1. This summation we can write in this way. If I substitute m is equal to 0, I will get 1. 1 minus 1 will be 0. That is cancelled out. Next leftover part is from m is equal to 1 to infinity. The values idde irutte. That's why we can write this as this equation. I hope you are able to write the summation. Okay, for this one, what is the equation? 3 divided by 1 minus 1 by 2 is there. Okay, that is 1 minus sorry for that, minus 1 by 2 z inverse. This is the answer, minus 2, and this is 1 divided by 1 minus 3 z inverse, minus into minus plus 2. Okay, so this is what we are going to get finally. Now let us solve this. Minus of 1 by 2 is plus, so I will write it as 1 divided by 1 plus 1 by 2 z inverse minus 2 divided by 1 minus 3 z inverse plus 2. Okay, so we can now simplify it. I will not go to the simplification aspects, so we can solve another problem. That's why I will go to the answer. Okay, here we need to remember that what is the ROC of this one and what is the ROC of this one. Okay, ROC of this one is, for a right-sided sequence, ROC of this sequence is 1 by 2 z inverse. Magnitude of 1 by 2 z inverse is less than 1. For this, for 3 z inverse less than 1. So that means 1 by 2 z inverse z, sorry, 1 by, let me finish this ROC part, then we will be clear with the concept now. So here magnitude is there. Always we take ROC with magnitude because it is right as well as left side. Circle will be having both negative and positive part. So 1 by 2 z inverse less than 1. This means 1 divided by 2z less than 1. This implies 1 divided by 2 is less than z, or magnitude of z is greater than 1 by 2. Okay, this is for first sequence, first term. For the second term, 3z inverse magnitude should be less than 1. This implies 3 by z is less than 1. Correct? So it's correct, right? 3 less than z. Is there any mistake here? Give me a second. Not operating. the basic rule which I forgot to mention here. For this one it is correct. Z is greater than 1 by 2. For a left-sided sequence, what we have? 3Z inverse is greater than 1. So Z inverse, 3 by Z is greater than 1, or Z is less than 3. So for left-sided sequence, this is the rule what we have. So based on this, what we get is Z is greater than 1 by 2 but less than 3. So plot is like this. There is a pole at 1 by 2. There is another pole at 3. So the ROC is between these two poles. This is our Z plane. Imaginary of Z, real part of Z. Okay. So this is for right-sided sequence. We know that, right? Right-sided sequence. This is the condition. Left-sided. This is the condition. So we will get ROC as this one. Okay. So that completes this problem. Okay, this is just simplification as I already told. So if you simplify, you will get this as the answer. Now next problem, you please solve it, because it is also a similar problem, only the values are different. 3 to the power, you can see here, it is also similar problem, only here you will get panic with this equation. So 3 to the power n plus 1, how to solve it? 3 to the power n, 3 to the power 1. So 3 to the power 1 is independent, you can take it out. 3 to the power n, here it is same as previous one. Again here it is, instead of minus 1 by 2 here, we have 3 to the power n. Instead of 3 to the power n, we have plus 1 by 2 here. Okay, so finally we can apply the same logic which we have used earlier, and we'll get this as our answer. And you can easily remember that if something is there inside this, like minus 1 by 2, it will become Z divided by Z plus 1 by 2. If it is plus 1 by 2, it will become Z divided by Z minus 1 by 2. Okay, so remember it easily. Yes, what is the problem? So this is the problem which you can solve. And about the ROC cannot be found for this sequence. That I will explain tomorrow why it is so. Okay, for this particular sequence, ROC cannot be found. Then this is the another sequence. This one also you can try, because based on the previous problem only, this is also there. I will just explain it tomorrow. So go through this problem, and this is the easiest one which we have already solved. This 16th one, 15th one and 14th one I will solve tomorrow quickly, and other problems you have to solve. Okay, here based on the properties, that is P17, from here onwards we will solve the problems. Other problems I will just run through some of the important points how to solve the problems. Okay, so these are important based on properties again. So we'll solve these problems tomorrow. Now let me take the attendance. Answer attendance, Anshul.
Yes, sir.
Second. Arpita, Bharat,
Present, sir.
Present, sir.
Bhumika,
Present, sir.
Harshita, CS Harshita, Darshan, Darshan K, Darshanyam,
Yes, sir.
Darshanyan, Darshan SV,
Present, sir.
Danya,
Present, sir.
Gautam, Gautam, Shivakumar,
Present, sir.
Harshita P,
Present, sir.
Harshita S,
Present, sir.
Manasa, Manjesh,
Present, sir.
Maulya,
Present, sir.
Niharika, Niharika, Nisarga,
Present, sir. Present, sir.
who is that Niharika?
Sir, Nisarga present.
Pavana,
Present, sir.
Purvika,
Present, sir.
Pradeep,
Present, sir.
Rachana,
Present, sir.
Rajat,
sir.
okay. Rajat, Rajesh, Rajesh,
Sir.
okay. Rashmi,
Present, sir.
Ritik,
Present, sir.
Tejas, Tulsi, Tulsi, Varun,
Present, sir.
Vikshit, Vinayaka,
Sir. Present, sir.
Yogendra,
Yes, sir.
Yogesh,
Yes, sir.
Ashok,
Yes, sir.
Danit,
Present, sir.
Kruti,
Present, sir.
Manoj,
Yes, sir.
Nagendra,
Present, sir.
Sukit,
Present, sir.
Vikas.
Yes, sir.
So absentees are Vikshit, Tulsi, Tejas.
Sir, sir. Present, sir.
ಅವಾಗಲೇ ಏನಕ್ಕಪ್ಪ attendance ಹೇಳಿಲ್ಲ?
Sir, ಇದು ನೆಟ್ವರ್ಕ್ ಇದೆ ಸ್ಟಕ್ ಆಗುತ್ತೆ.
Harshita, okay, not Harshita. CS Harshita, Darshan K, Gautam, Manasa, Niharika, and Rajat. Okay.
Sir, in present, sir.
Darshan, yeah, I am talking about Darshan K.
Okay, sir. Thank you.
Okay. Thank you for joining. Please go through the notes, otherwise it will be very difficult to solve the transform. Thank you.